In previous videos, we looked at how to find the nth term of a geometric sequence, that is, find a specific term or find the sum of the terms of a geometric sequence where it was a finite sequence. In this video, we're going to look at how to compute the sum of an infinite geometric series, if it exists. So let me just show you the problems that we have here. If you want to try these, pause the video. There's 5 problems. Okay, so let's look at the first one. This one, they give you the extra terms. No summation. We have 1 plus 1/3 plus 1/9. 3 dots means it goes on forever. So this is an infinite. These are all infinite geometric series because we're adding the terms. So let's look at the formulas real quick here. We've gone over some of these already. The one we want to look at is this one here. If you want to add the sum of the first n terms of a geometric sequence, this was the formula. If you know the first term and the common ratio, you know how many terms you're going to add, just plug it into this formula. Now in this video we're going to look at n is finite here. What happens if we're going from 1 to infinity? Now let's suppose, to start off with here, that the common ratio is something like 1/2 or -1/2. In other words, let's suppose it's a fraction between -1 and 1. Well, if I make this exponent real large, say 100 or 1,000, this could go to 0. Right? As you take 1/2 to the first power, so you got, and then to the second, then to the third, so you have 1/2, and then 1/4, and then 1/8, and then 1/16. So this denominator is going to be getting larger and larger, a lot quicker than the numerator. It's going to stay at 1 in this case, so this is going to go to 0. So the point is then, in this formula, if r is between -1 and 1, not including 1, not including -1, in between, then this is going to go to 0. So you're going to be left with a1 times 1, so it'd be a1 over 1 minus r. And that's the formula that you're going to use to find the sum of an infinite geometric series, if it exists. So with that in mind, that means, as I just said, if the common ratio is less than 1, which means that absolute value of r less than 1 means r has to be between -1 and 1. So it could be 1/2, -1/2, 1/3, -1/3. So here's the formula you'll be using. Anything in this form, if this r right here is between -1 and 1, it's going to converge, which means it has a sum. And you can find that sum by plugging it into this formula. First term over 1 minus the common ratio. So you can see that if r is larger than 1, let's say the first term is 1, and we're multiplying by 2. R is 2. And 2 times 1 will give me 2. And 2 times 2 will give me 4. Then 2 times 4 will give me 8. And then 16. And so on. So if I want to find this sum, it's going to diverge. It's not going to approach any particular number, so it get larger and larger and larger. So this one is not going to have a sum, or we say the series diverges. So with that in mind, let's look at the first problem. Got 1 plus 1/3 plus 1/9, and it goes on forever. So first you know the first term right there. Find the common ratio. So take any 2 consecutive terms and form the quotient. So we can say 1/3 over 1. Or if you can figure out what you're multiplying by, well, you can see 1 times 1/3 is 1/3. 1/3 times 1/3 is 1/9. And then 1/9 times 1/3 is 1/27. So it should be clear that the first term is 1. And the common ratio is equal to 1/3. And all you have to decide is 1/3 between -1 and 1. It's 1/3 between -1 and 1. And it is. So this series converges. And we find the sum here using the formula that I just went over. First term on top, which is 1, over 1 minus the common ratio, which is 1/3. 1 minus 1/3 is 2/3. So this just gives me 1 divided by 2/3. Invert and multiply here. So the sum is 3/2. That's your answer. Number 1 converges, and the sum is 3/2. Now the next one here, take 12 over 8, reduce it. Point to 12 is 3, point to 8 is 2, and then just check it here. I multiply 8 by 3/2, get 12. I multiply 12 by 3/2, I get 18. I multiply 18 by 3/2, I get 27. So just double checking that that is an infinite series, and that our common ratio is 3/2. 3/2 is larger than 1. It's not between -1 and 1. So this one diverges. The main thing you want to know is if it converges, R has to be between -1 and 1. Okay, now here they give you a summation. K equal 1 to infinity. So just write a few terms here. When k is equal to 1, got 1 minus 1 is 0. So 1/4 to the 0 is 1 times 5. You get 5. So the first term is 5. When k is 2, 2 minus 1 is 1. So this gives me 5 times 1/4. And if you pick a few more values for k, you'll see that basically you're multiplying by 1/4. So the first term is 5, and the common ratio is 1/4. 1/4 is between -1 and 1. So this one converges. And we can find the sum using the formula. This went over the sum, first term on top, that's 5 over 1 minus 1/4. This will be 5, then 1 minus 1/4 is 3/4. 5 divided by 3/4, invert and multiply, it will give me 20 over 3. So this one converges. The sum is 20/3. Now for the next one, notice, if I put a 1, k equal 1 to infinity, if I put a 1 there, that'll give me 3 to the 0, I get 1/2. So we know that 1/2 is the first term. But then we put in 2, and we get 3, so it's multiplying by 3. Every time we put a value, all it's doing is multiplying the previous term by 3. 3 is not between -1 and 1, so this one diverges. Okay, let's look at the next one. This one goes from k equal 1 to infinity, and it's 2 times 3/4 to the k power. So let's pick k to be 1 in this case. So this will be 2, k is 1, so this is multiplied by 3/4. That's the first term. And I put k to be 2, the next one would be 2, 3/4 to the second, and so on. So the first term, this multiplies this out 6/4. We can reduce this to 3/2. And the common ratio should be clear. The common ratio is 3/4. So this one converges. And the sum will equal to, first term is 3/2 over 1 minus the common ratio, which is 3/4. We'll get 3/4, and then 1 minus 3/4 is 1/4. Invert and multiply here, so it would be 3/2 times 4/1, give me 6. So converges, and the sum is 6. Thanks for watching. We'll see you next time.